Hello, my dear students and the rest of the learners. Welcome to part 24 of a 29-part series of tutorials in Fundamentals of Structured Programming using C. In this presentation, we are going to be looking at how you can sort an array using the technique that we call bubble sort algorithm. Therefore, the title of this presentation is sorting an array using bubble sort algorithm. My name is Memedi M, or you can simply call me Emily Swap. What is sorting? Sorting is the process of organizing or arranging data in a certain manner, such as in ascending or descending order. These are various ways, or there are various ways of sorting data in an array, such as bubble sort, selection sort, insertion sort, quick sort, merge sort, amongst others. But what matters at the end of the day is to have your array elements or the elements in your array arranged in a certain order, either in ascending or descending order. And the method that is going to be used, whether ascending or descending order, depends on the way you do your coding. The idea behind this algorithm, especially the idea behind bubble sort, is to scan through the list of array elements as you compare every two adjacent elements in order to see if they are in order, and then you swap them if they are not in order, and then you continue doing the same with the rest of the elements. Once you reach the last element in the list, you are said to have completed the first pass. Then you repeat this process again from the first element in the list to the last element as you interchange any two adjacent elements that may not be in the intended order up to the last element in the list. This is called the second pass. And therefore, you continue repeating this process again and again until all the elements are in order. And how do you know that the elements are in order so that the sorting process can stop? You know, or you are able to tell that all the elements have been sorted if you carry out a complete pass without, or a complete a process of checking or context checking or scanning the elements without swapping any. So if you begin, or if the processor begins comparing the elements from the first element in the array until it reaches the end of the list without having done any swapping, it means, or that will inform the processor that the elements are already in order. They have already been sorted, and therefore that will mark the end, or that marks the end of the sorting process. So just as I've said, you are able to know that the elements have been sorted when you complete a pass without having swapped any elements. This implies that this sorting technique entails sorting for inner loop and for outer loop. Therefore, the sorting for inner loop is completed in n-1 iterations of the outer loop, which means that if, for example, you have 9 elements in the array, then the inner loop, or the sorting of the inner loop, is completed in the 8th iteration, that is 9-1, if you have 9 elements. For example, if an array has the following elements, the array is called this course, and it has elements as 45, 90, 20, 53, 100, 15, 78, 34, 11, and 60, the sorted array will look as follows. So this will be the sorted array: 11, 15, 20, 34, 45, 53, 60, 78, 90, and 100. So the following is thus a program implementing bubble sort to arrange the following elements into ascending order using functions and displays the elements on the screen. So before we write this program, I would like you to have a look at how that sorting will be done or how the processor will do it. So this is our elements, or this is our array. Now, if you have this array and you are using or you are making use of what we are calling the bubble sort technique, which already we have seen here. Remember, our title is sorting using bubble sort. And we have said that the sorting process entails interchanging or swapping elements that are not in order, and the process continues until all the elements have been sorted. So how does this process occur? So I want you to have a look at this table here. This is where I have done for you the sorting. Initially, you have your values arranged in their order. Those are the elements that have to be sorted. As you can see, that is the initial array. So when you begin now comparing for the first pass, the processor will compare the first two elements, as you can see. If the first two elements are already in order, that array will remain. There will be no swapping of the two elements. The next step is to compare the two elements, 90 and 20. You can see that 20 is smaller than 90, and therefore swapping will be done, and then your array will look as follows. So we have already swapped the first and second elements. Then, in the third pass, we compare the third and the fourth element. You can see 53 is bigger than 90, so we swap them or we interchange them, and therefore it will look at as 45, 20, 53, 90, that way up the last element. Then we compare the fourth and the fifth element. As you can see, these ones are already in order, so no swapping will be done. Then we compare the sixth or the fifth and the sixth element, 115. 15 is more than 100, so we swap them. Next, we compare the sixth and the seventh element, 178. As you can see, 78 is smaller than 100, so we swap them. Then we compare the eighth, the seventh, and the eighth elements, 134. 34 is smaller than 100, so we swap them. Then we compare the seventh and the eighth and the ninth elements. You can see 11 is smaller than 100, so we swap them. Then lastly, we compare the ninth and the 10th element, 160. You can see 60 is smaller than 100, so we swap them. So in the first pass, we are going to have our elements as 45, 20, 53, 90, 15, 78, 34, 11, 60, and 100. So you can see that this is our array elements in the first pass. So in the second pass, we continue again. We begin again in the first round. We compare the elements. The first two, if they are bigger, like in this case, 20 is more than 45, we swap them. We compare the second and the third. These ones are in order. We compare the third and the fourth. Those ones are in order. We compare the fourth and the fifth. You can see they are not in order, so we swap 15 and 90. Then we compare the fifth and the sixth. You can see they are not in order, so we swap them. Next, the processor compares the sixth and the seventh element. You can see they are not in order, it swaps them. Next, we compare the seventh and the eighth elements. You can see they are not in order, we swap them. Next, we compare the eighth and the ninth element. You can see they are not in order, so we swap them. Lastly, we compare the ninth and the 10th element. We compare the 9th and the 10th element, and then we swap them. So in the learned pass, you have our elements like that. So we continue comparing and swapping our elements. We continue comparing and swapping our elements all the way to the 9th pass. Note, our number of elements are 10. So by the time we are doing our 9th pass, our array will have been sorted. So let's look at our 9th pass. We compare the first two elements, 11 and 15, in order, no swapping. Then next, we compare the second and the third element, in order, no swapping. We compare the third and the fourth element, in order, swapping. We compare the fourth and the fifth element, in order, no swapping. Then we compare the fifth and the sixth elements, in order, no swapping. We compare the sixth and seventh element, in order, no swapping. We compare the seventh and the eighth elements, in order, no swapping. We compare the eighth and the ninth elements. You can see the in order, no swapping. And lastly, we compare the ninth and the 10th element. As you can see, the in order, no swapping. So my dear students and the rest of the learners, you can see that by the time we are performing our last pass, we compare all the elements from the beginning to confirm that for sure the elements are in sorted order. And once you notice that all the elements are in order and there's no swapping which is done, then it simply means that our elements are in sorted order, and therefore that marks the end of the sorting process. So this program, the program that will do what I've explained, will look as follows. So our comment is implementing bubble sort using functions. Then we are defining or declaring a constant by the name size, which is supposed to hold the size of the array. And then we have our function prototypes here. These are our functions prototypes. The first function is called input array. It's not going to return any value, but it's going to receive an array called scores. The next one is a function called display array. It is going to receive a function called, or it is going to receive an array called scores of type integer. Now note here, this is a comment. This is a comment for inputting elements into the array. Input array. Now, if it remains as a comment this way, do you think that the computation will be done? No, this function will not be invoked. So let me remove this error. This is an error. If it remains as a comment, the function will not be, the prototype will not be executed. So that's a correction. So our function prototypes are void. The function prototype is void input array. So this is the first function which will be executed. So when I say the first, it's a first here, but it will depend with the core statements how they are going to look like. So the first function is called input array. It's going to receive a parameter which is an array of type integer. The second one is display array. It's going to receive a function. It's going to receive an array called scores of type integer. The other function prototype is bubble sort. The one which is going to be doing the sorting is going to receive an array of type integer called scores. The other one is to display the sorted array. It's also going to receive an array of type integer, and those are the prototypes we shall have. Then we have our main function here. We are declaring declaring an array called scores of size 10, and those values will be of type integer, and we're initializing that array with elements in the following order. So this is a one-dimensional array called scores, and it's being assigned the following values by the processor, or automatically once this statement is executed. The values will be 45, 90, 20, 53, 100, 15, 78, 34, 11, and 60. So these elements will be stored in the array memory location called scores that we have already requested the processor to set aside. From there, as you can see, we are supposed to invoke the function called input array. Now, the question here, my dear students and the rest of the learners, is this. And I'm doing this for the purposes of helping you understand. If we have already initialized our array, the question is, do we really need to invoke the function for entering the values? No. So whereas I've done the prototype at the top here, even if I invoke, or even if I don't invoke that function using this function call, then that prototype will not be used. Now let's proceed and see how the definition will look like. So these are function calls, these are call statements. Then the definition for the functions are here. You can see I have the definition for the function for displaying the array elements. And this function is going to display those elements on the screen. The second function is for sorting the array, which is this function here that I will explain just now. The third function is for displaying the sorted array, similar to the program we discussed earlier in the previous presentation. So what we are going to do is, because already I have initialized my array at this point, I'm going to make this prototype to be a comment. Just show you that if you're going to prompt the user to enter values, then you have to have this prototype active without making it a comment. You have also to include that here in the call statement, so don't you remove the comment, and then you ensure that you define your function for inputting values after main, just the way I've done for the other functions. So let me make my functions comment. So I'll make this prototype a comment because I will not use it. My dear students and the rest of the learners, I hope you have seen, you have known why I've made input array a comment, just to help you when you are coding your program and you want from the user to enter values in the array. You can do it, but then you don't put a comment here for the prototype. For you to be able to learn on how to read values into the array, I kindly advise that you go through the previous presentation that has been posted in the Meriswap ICT YouTube channel. That is presentation number 23, in which I talked about how to enter values into an array. But in our case, I've already initialized my array with the values, and therefore I don't need to have or prompt the user to enter the values again. Now let's see how this function for sorting the array is going to work. Let's have a look at this function called bubble sort. If you look here, the name of the function is bubble sort. It's receiving the array called scores, or the memory location for the array called scores. From here, inside here, I have two parameters. Let me have the whole of it there for explanation purposes. So we have two local variables, one called the pass, the other one three of them, one called pass, the other one is j, the other one is 10. So we are beginning with initializing the memory location called pass with 1. Then we check, is the content of pass less than size? Remember, the value of size is 10. I have made it a constant in the program as you have seen. So is 1 less than 10? Yes. So if that is true, if the pass has not been exceeded, meaning that we have not exceeded the number of elements, then we do the following. Initialize j, memory location called j, with 0. Then check if the content of j is less than size. So a0 less than 10 minus 1. What this part is doing, it is controlling the number of comparisons per pass. Because at the end of the day, the last pass is supposed to be the size of the array subtracted 1. So if the number of elements are 10, comparison should be done up to the 9th pass. Why? Because by the 9th pass, the elements have been put in order. So if that is true, if the value of pass, if you are within first pass, and you have not exceeded the number of elements, then do the following. You compare the elements and you swap them in order. Pick the element whose subscript is scores 0. That means the first element. Check, find out whether it is greater than the second element, that is 0 plus 1. So compare scores 0, that is scores subscript 0, and the scores subscript 1. This means the first and the second element. Compare them. If what is in the first position is bigger than what is in the second position, if what is in the first position is bigger than what is in second position, do the following. Pick what is in the first position, assign it in a memory location called temp. Then pick what is in the second position, assign it in the memory location for the first position. Then pick what is in the memory location called temporary and assign it in the second, in the memory location whose subscript is second, that is 0 plus 1. Then once this brace is encountered, increment the value of pass of j with 1. So if j was 0, make it 1. Then compare. Is 1 less than 10 minus 1 less than 9? If yes, compare now what is in scores 1, subscript 1, that is second, with 1 plus 1, that is third. So compare what is in scores subscript 1 and scores subscript 2. If what is in scores subscript 1 is bigger than what is in scores subscript 2, perform this activity. So this will continue until when what is in memory location called j is not less than 10 minus 1, or the number of array elements minus 1. Then if that is true, this loop will be exceeded. And then the control will be taken to this path or part of the loop, which is the value of memory option called the pass plus 1. So initially it was 1, pass the pass. So 1 plus 1 is 2. So it will check, is 2 less than 10? Yes. If that is true, the process will enter in this loop, perform the same operation as we have discussed, and once that embraces a content, or once the value of j is no longer less than or equals to, is no longer less than size minus pass, like 10 minus 1. Once it's no longer less than 10 minus 1, the control will again be taken out here. And this will continue. The control will be brought here. The value of pass will be incremented. The condition will be checked. And once the value of pass is no longer less than size, that means when pass will be 11. 11 can't be less than 10. In fact, not 11, but 10. Once value of pass is less than 10, is 10 less than 10? No. Is 10 less than 10? No. So that means simply once the value of pass, once the value of pass or the content of the memory option called the pass is not less than the value of size, that is 10, then this loop or this function will come to an end. So that's how the bubble sort will work. And then the rest is to display the values from the array. And for you to learn about how the displaying of the values from the array works, just go through the previous presentations. That is part 23 of the series, and also part 22, in which we learned about how to read elements from an array and display them on the screen. In addition, the following is a program that implements array passing to functions, allows the user to specify the size for his or her array by specifying the number of elements to be entered, and then it prompts him or her to enter the elements into the array, display the unsorted array on the screen, then sorts them in ascending order using bubble sort, and display the sorted array. In other words, my dear students and the rest of the learners, the difference between this program that we have discussed and the other program that we are about to learn is simply this, that this program contains an array which has already been initialized. So the user is not being given the freedom to decide the size of the array, nor to decide or make a decision on the elements that he or she wants to sort. But in ordinary life, a good program is the one which allows the user to decide how many values he or she wants to enter. Are they 50? Are they 100? Because the challenge is how to sort the values and identify maybe the first one, the one which is the highest. For example, if you have 1,000 students and you have administered an examination to them, you want to organize them or arrange them from the highest scorer to the least scorer, or from the least to the highest. Then it means that you have to write a good program that will prompt the user to identify the number of elements to be sorted, and also give the user the opportunity to key in those values. And then the program is going to sort them out and also perform other operations. And therefore, the limitation with this program is that this program is working with the already identified elements. And therefore, the purpose of this program is just for learning purposes. But in online life, we need to write programs that can allow the user to decide how many number of elements he or she wants to sort, and also allow him or her to specify those specific elements that he or she wants to enter into the array and then sort them. And that's a program that I want us to discuss now. So this is the program. So the program begins with a comment. This program uses functions and array parsing to sort any array size. That's our preprocessing directive there. And then we prototype our functions. The first prototype is for a function called input array. It is going to receive an array memory location called scores. So the name of the memory location to be passed to this array is input scores. This scores. And this array called scores will hold values of type integer, and its size has been passed. So this is function prototype for inputting values into the array. The next function prototype is for displaying the array. It's receiving the memory location for the array, and it is also receiving the size of the array. Then the next prototype is for doing the bubble sort that you have already discussed. It is receiving the array, that is the memory location for the array, and its size. The other one is for displaying the values from the array, and the name of this function is display sorted. That's the name of our array. It's also receiving the array and its size. So once you do the prototypes, you have declared the functions. We go to the main. Under the main, we are declaring a memory location called size. We want values of type size or type integer. The memory location's name is size, and is going to hold the values of type integer. The statement to be displayed on the screen is how many elements do you want to enter in the array. You allow the user to specify the number of elements, and that value is going to be stored in the memory location called size. Then from there, we declare a memory location. We declare an array. The name of the array is called scores, and the size of that array will be the size of the value that has been entered by the user. So the processor will know the size of this array by reading the value of the memory location called size. If, for example, the user has entered 10, and 10 has been stored in memory location called size, then this array will read as set memory location aside called scores to hold values which do not exceed 10, assuming that the user has entered 10 as the number of elements. From there, we invoke our functions. The first function to invoke is the one for inputting the elements into the array. So the array or the input statement is, or the call statement is called input array, and then we pass into it the name of the array, which is scores, and the size of that array. So once this statement is invoked, the control will be taken to this prototype, and then the function or the processor will go and look for that array's definition past or after the main. And here it is. This is the function, or this is the function definition for entering values into the array. So once the control is brought into this function's definition, this function or the control will do the following, or the processor will do the following. It is going to set a memory location assigned called I, which is going to hold the value of type integer. And then it will display this statement on the screen. Enter there. It will pick or read the content of the memory location called size and display on the screen at where we have the type identifier. So if, for example, the content of memory location called size is 10, the statement will read as enter the 10 elements to be sorted. Then the next statement here will display the name index or the text index on the screen. And then this loop will control the reading of the values. So first, the processor will initialize, or the control will initialize, or the processor will initialize the memory location code I with value 0, then check if the current content of memory location code I is less than size. So based on the value the user has entered, if the size entered is 10, it will compare. Is 0 less than 10? Yes. If the condition is true, it will do the following. 1, it will display the content of memory location code I, that is the index. So if it reads 0, it will display 0 spaced with 4 characters. Then it will request the user to enter a value. That value will be stored in the memory location code scores 0. That means the first position in the array. Once that is done, and this is an accountant, the processor will increment the content of memory location code I with 1. So if it was 0, it will be incremented with 1. That means 0 plus 1. So that will be 0 plus 1 is 1. Then it will display the index as 1. It will print or display the index as 1, spaced to 4 characters. And then the user will key in the next value, which is going to be stored in memory location code scores 1. Then once this places an accountant, the processor will go to the last part of this statement, that is I plus plus, that is it will increment the content of memory location code I, check the condition, and that will continue. This process will continue until when the value of I will not be less than size. That means all the elements have been entered, and therefore the processor will exit the loop and print out a blank line on the screen. So that's how that function for inputting array will work. So once that is done, the control will be taken back to the main program. And the next statement to be executed or be invoked is this one, display array. So the function which will be invoked is called display array, and it will be passed to it the array or the scores and its size. So once this statement is invoked, the control will be taken to this prototype, and then it will go and look for that function definition after main. That is the function for displaying the array. So the control will be brought here, and this activity will be performed. The activities listed here will be performed. And this part will read is for reading the elements from the array, beginning from scores 0, writing it on the screen, scores index 1, scores index 2, all the way to the last value of index. So those elements will be displayed on the screen, and that is what this function will do. Once all the values have been displayed, the control, in other words, once the value of I, or the value of the memory location code I, will not be less than size, or the content of memory location code size, the loop will then exit, and the control will be taken back to the main program, which will then come here to bubble sort, which is the function for doing the sorting. So once this statement is read, which is invoking the function called bubble sort and passing into it the array called the scores and its size, the control will look for that function. It will encounter that this function has been prototyped here, meaning that the definition is after main. So the control will be taken after main, and the processor will look for that function called bubble sort. So it will come here and perform the operation of sorting the elements, just as I have explained in the other program that was initializing the array through the code. So the swapping will be done. Now, if you check here, I have changed this part. The other function, the other program that we looked into was sorting the elements in descending order. But this one is sorting in ascending order. Why am I saying that? If you check on the if here, let us go to that program for you to see. If you look at this, this function here, if you have looked here, this function is comparing. If the value in scores j is greater than the scores j plus 1, that means if the previous value is greater than the second value, if, for example, j is subscript 0 and the second one is subscript 1, if the value in subscript 0 is bigger than the one in subscript 2, we do the swapping. I want you to look at this part and ask yourself, if you wanted to sort this array such that you sort it in descending, where you have it run from the highest to the lowest. If this value is, if the first value is greater than the second value, would we interchange them or do we retain them as they are? We would retain them. So this sign here would not be greater than. We would use the less than, so that we bring the bigger one in front and the smaller one to follow next. By the way it is, this one will arrange them from the lowest to the highest. So this function here, if you wanted the sorting to be done in a way that the bigger value comes before the smaller value, such that the sorted array will have the value sorted from the highest to the lowest, then you could not, or you are not supposed to use the greater than sign here, but you are supposed to use the lesser than. So this one will sort from the lowest to the highest, and that function is similar to this function here for bubble sort. This one. Now, this part here, you can see that this function is also comparing. If the value in scores j is greater than scores j plus 1, we interchange them so that we bring the smaller one first and the bigger one follows. So this function is similar to the other function that we have discussed. So once this brace is encountered, the control will be taken to the main, and the next function or the next statement to be invoked is the one for displaying a sorted array, which once this statement is invoked, the control will be taken to the prototype for displaying the sorted array, and the control will be taken after main to look for the function for displaying the sorted array, and therefore the control will be brought to this point, and this function is going to read the values in the memory location or from the array and write them out on the screen but spaced 4 spaces. And once this is done, once this is encountered, the control will be taken back to the main program, that is to the main function, to the next line, which is to write a blank line or a new line, return the control back to the operating system, and the program. Therefore, my dear students and the rest of the learners, let's see how this program will behave when coded in Falcon IDE. The program that we are going to code is not the one which is doing the initialization through the code, but we are going to call the program which is prompting the user to enter values on the screen, or to key in the values to be sorted, and the sorting is done. However, you can also code this program yourself so that you can see how it will behave. But when I listen carefully, it seems that you also want us to code this program and run it in IDE, in Falcon IDE. No problem. Let us write one program or code this program, which I'm going to explain. We run it in Falcon IDE. We see how it will behave. And then we proceed and code this other program that is allowing the user to determine the size of the array and also the number of elements. And then we see how both of them will behave. So for us to begin, let us begin by coding this program. Let us begin by coding this program that is already initializing our array with values, and then we see how it will behave so that we can compare it with the other one and see the best one for us to use in our ordinary day lives. So for us to proceed, you just need to launch Falcon IDE, key in this program in your editor, save it, compile it, and execute it as follows. So let's launch Falcon IDE. So we search for Falcon app. Then we create our project. Now this project, we are going to call it sort, or let's call it sorting, bubble sorting array. Bubble sorting, bubble sorting array, bubble sorting array. Compiler is type C. Then we create a file under that project, not project. Let's cancel that. We create a file, new C file. We name it to bubble. Let's just call it bubble sorting array. And then we can code our program here. So that is our program, which we have already discussed. It is well indented. Ensure you indent it nicely. So that is our program. You know, it's good to ensure that your program is well indented, my dear students and the rest of the learners, so that you are able to follow each of the parts easily, like that. And we also have the one for displaying the sorted array there. Then we can save all the name will remain unsorted, bubble sorting array. So we have saved the project and the file name. Then we compile it. You can see that our program does not have any errors because compilation has been successful in 1.0.047 seconds. So from there, we can just run our program and we are going to see the results straight away because the user is not going to enter anything, as you can see. So just as you can see, this program is purely for learning purposes. It's not giving the user an opportunity to determine the size of the array or the elements to be entered into the array. So that's our program. Here is the order of elements before printing. You can see that's a statement I have in my program and the first function for displaying the array. And then we have the function for putting the array elements. You can see it has done its work. We have our array elements there. And then here are the sorted elements using bubble sort. You can see they have been sorted nicely. And their order is 11, 15, 20, 34, 45, 53, 60, 78, 90, and the highest is 100. So they are sorted in ascending order. Now let's go back to our program. We close this program. So close all. We can also close our project that way. And then let's write our second program, which I've said it's the best one for ordinary life, this program. So we are going to code this other program, which is very flexible, the one which is going to allow us to enter any number of elements and we sort them. So you can code this program in your computer that is using Falcon IDE. You code it or you write it in a word processor like Wordpad, Notepad, or any other, then just copy it and paste it into the IDE for Falcon for the purposes of compilation and running the program as we are going to do. So what we are going to do is we are going to launch Falcon again and we key in this program. Then we see how it is going to work. So for us to do that, we are going to launch Falcon as usual. So I have it here. Then we click on File, New. By now, my dear students and the rest of the learners, if you have been following the series of presentations, I believe that you are now proficient in the process that we follow when we are creating a project or even a file. So this one, I will call it bubble sort user entry. I will call it sorting user entry. Sorting user entry. Bubble sorting user entry. Bubble sorting user entry. The compiler type is C, and then I'll click finish. Then you can create a file, that is C file, rename it. I'll rename it using the same one because this is a sorting, bubble sorting, values entered by the user. It will be sorting, bubble sorting user entry, meaning the values which will be sorted are the ones which have been filled in by the user. From there, you can type your program here or just paste your program from your processor. You want the program, or you want that's from the processor. If you have already typed it, like in my case. So let's have our program here in our IDE. So I'll just paste my program here. Paste the program that we have already discussed. Ensure that every part is well indented. Here are my prototypes, which we have already discussed. This is the main program, and I have my core statements there for each of the functions. I have the function for entering the values here, as you can see. Ensure it is well indented. So that is our first function for inputting values. Then we have the second function here for displaying the elements in the array. Then we have the function definition for bubble sorting, which we have already discussed here. I'm ensuring that it is well indented. So there we are. So that is the function for sorting. It's called bubble sort. And then lastly, we have the function for displaying the values from our array. That is a sorted array elements there. So once you have coded your program that we have discussed, save your program by clicking on Save All, because Save All allows you to save the project as well as the project name and ensure that the location is accurate. Then from there, let's compile our program. You can see our compilation is successful as indicated in the status bar for the Falcon IDE. That means that our program has no errors, and therefore we can proceed and run our program. We expect this program that is going to ask the user to specify the size of the array. As you can see, how many elements do you want to enter into the array? I can enter, for example, 15. You can see. Then it's prompting us to enter the 15 elements to be sorted. This is a very good program, my dear students and the rest of the learners, that is flexible. It allows you to write or to code a program that helps you specify the number of elements you want in your array, and you key them in so that it's able to sort for you. Very flexible. So this program can be used to sort any number of elements. So let me enter some figures, 15 values. I am keying in my elements. Once I enter the 14th one, because that is the array scores index 14, I expect this program that it will move on, display the sort the elements, and also display them. And remember, even if you want to perform another operation, once you have entered your values in the array, you can perform them as learned earlier. I want to have this one as 310. So you can see, once you press enter, you can see that our elements have been sorted. So here is the order of the 15 elements before sorting. You can see. So the first output statement there for the values is showing you the values just as I've entered them. And then you can see here are the 15 sorted elements using bubble sort. So my program has been able to sort the values that I've entered. And you can see they are spanning from 1, 11, 23, 34, 34, That means we have 234s in our program. 45, 54, 66. You can see 76, 76. They are following each other. 89, 89. 90, 100, and 310. So you can see that even if you have elements that are similar, they'll be displayed next to each other. They'll be organized together. This is good. So let's indicate continue. So this is a very good program. It's a very good program which you can copy and practice using any number of elements. So the beauty with this program is that it is allowing you to specify the number of elements you want to sort, and it gives you the opportunity to key in those elements, and then it sorts them out. If you want them to compute their total ETC, you just need to add another for loop for computing, and then you display the results, as we have learned previously in the previous programs in this series for the arrays. And with that, we can save this program, that is save all the files written this project, and then we close all files. We can exit from Falcon IDE, and that marks the end of part 24 of the series. You can now proceed to watch, listen, and practice part 25 of the 29-part series, in which we are going to learn about how to search for an element in an array using linear search technique. Congratulations for learning part 24 of 29 on sorting an array using bubble sort algorithm in fundamentals of structured programming using C. You can access the rest of the parts in the series, as well as other computer or ICT videos, by clicking or tapping on the Mediswap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Remember, you can also join this channel as a special member to enjoy additional privileges by clicking on the join button, which is just next to the name of the channel, Emilyswap ICT YouTube channel, and then you can choose your pack or your level of membership that you are interested with, so that you can enjoy more additional personalized or individualized services from Emilyswap himself. Thank you very much for listening to me, and let's meet in part 25 of the series, and God bless.